Hey there everybody, welcome. This is the second video in our logic primer series. You'll use this stuff directly in any class that involves proofs, which for many are introduced in geometry, but frankly can pop up anywhere, even when you least expect them to. And more generally, logic is fundamental to all mathematics and really fundamental outside of mathematics too. And so this provides a foundation for any future math course you take, even if they don't talk about it in that course directly. For this video, you mostly need the stuff we covered in the previous video, so you can see the link on the screen if you need a refresher. But you should be able to recognize statements in the context of logic. Remember, these had to be complete sentences that can be either true or false. And you should be able to determine truth values of simple statements at the level of the examples we discussed in the previous video. It's helpful if you've seen intersection and union of sets, but it's not necessary to meet the learning outcomes of the video. It might add a little bit more depth to the concepts, and it's also something we'll address in a video later on. After watching this video and practicing along, you should be able to define conjunctions and disjunctions, which are statements that use the words and or, and you should be able to determine truth values of those types of statements. All right, let's do some maths. So, compound statements are logical statements in their own right that contain simpler statements as parts. So, depending on what type of compound statement you're dealing with, and depending on the truth values of the simple statements that make it up, that's what determines the truth value of the compound statement. So the compound statements we talk about today are called conjunctions and disjunctions. So first of all, statements with and. Let P and Q be two statements. And remember, here variables can take the place of statements instead of numbers if we need them to. The conjunction P and Q is true whenever both P and Q are true individually. Okay, and so if P is a true statement on its own and Q is a true statement on its own, then the compound statement, the conjunction P and Q, will be true. There's some notation we can use as well. In place of the word and, instead of writing it every time, we use this symbol, this upward pointing angle. Okay, and so that's similar to the twiddle that we use for the word not in part 1. So when we write P, this upward angle, Q, we just read that as P and Q. So here's an example of a conjunction that's true. Spinach is green and fish breathe underwater. Okay, the first simple statement is spinach is green. Hopefully that one's true. And fish breathe underwater. They use gills to do so. That one is true. And so since both of these simple statements are true, the conjunction is true. And if it's helpful, we often call conjunctions and statements. And so if you don't like saying the word conjunction every time, that's okay. Most people will understand exactly what you mean if you just call it an and statement. And if you hear someone else say an and statement, you know that this is what they're talking about. Okay, so we can visualize this as well, this idea of a conjunction. And so here in one circle, we have every scenario where P is true, statement P, and in the other circle, we have every scenario where Q is true. And the region where the conjunction P and Q is true is exactly the intersection between circle P and circle Q. So there's a connection between conjunctions of statements and intersections of sets. And if you haven't seen that idea of intersection of sets, that's okay. We can just rely on our intuition here in the image, okay, that it's the literal intersection of these two circular regions. Here's an exercise. If you like, you can go ahead and pause the video and try these out on your own. What we're doing here is looking at two conjunctions and determining their truth value. That is determining whether the statements are true or false. Okay, and we're going to justify our response. So we're going to show our work effectively. So part A, blue is a color and 5 is odd. If we look at the first simple statement, blue is a color, that one's true. If we look at the second simple statement, 5 is odd, that one's also true. So both of these simple statements that comprise the conjunction are true. Since both of those are true, the and statement, the conjunction, is true. All right, part B. 2 is even and 2 is not prime. Okay, so first simple statement, 2 is even. That's true. 2 is not prime. That one is false because 2 is prime. And so since at least one of these simple statements was false, the overall and statement is false. All right, so that's how we handle conjunctions. We look at the 2 simple statements on either side of the word and determine their truth values. And in order to conclude that the conjunction is true, we require that both simple statements are true. So if at least one is false, the and statement is false. It's another way of saying it. All right, on to statements with or. These are our disjunctions. And so let P and Q be 2 statements. The disjunction P or Q is true whenever at least one of P or Q is true. Sometimes people get confused if they associate P or Q with a strict either or scenario. In this case, if both are true, that's still okay, right? So that's why I think the clearest way to say it is that if at least one is true, then the disjunction is true. And again, we have a notation. You just flip the notation for and upside down, and then you get the notation for or. So this downward facing angle is just a notational representation of the word or. So we read this P or Q. And here's an example of a true disjunction. Flute is a woodwind instrument, or clarinet is a percussion instrument. So flute is a woodwind instrument. That's the first simple statement here. And that is true. Even the ones that are made of metal, we still consider them to be a woodwind instrument. Clarinet is a percussion instrument. That one usually is considered to be false, but if you play the clarinet a certain way, like banging it on a drum or a table or something, then it becomes a percussion instrument. Either way, the first statement is definitely true, which means the disjunction is true. All right. Disjunctions are also called or statements, similar to the way that conjunctions are called and statements. So if you say or statement, this is the kind of structure that we're talking about, and this is how you determine its truth value. And again, we can visualize this type of compound statement. So here, circle P, every scenario where P is true, circle Q, every scenario where Q is true. The region where the disjunction P or Q is true is what we call the union between the 2 circles. We're uniting the circles together. So there's a connection between disjunctions of statements and unions of sets. Okay. Here's another exercise similar to the last one, but with disjunctions. We want to determine the truth value of both of these statements. If you want to, go ahead and pause the video here, try these on your own, and you can check and see how you did. So first up, part A, 10 is even or prime. 10 is even would be the first simple statement here, and that's true. Okay, 10 is an even number, it's a multiple of 2. Here it just says even or prime, so we have to infer what that second statement is. In this case, it would be 10 is prime. Okay, so what about that one? Is that true or false? Well, 10 can be written as 2 times 5, so 10 has factors other than 1 in itself, so 10 is not a prime number. This one is false. So what about the disjunction? Well, we only needed at least one statement to be true. And so since the first part was true, 10 is even, the overall or statement is true. Doesn't matter that 10 isn't a prime number. Okay, part B, red is an integer or 2 is a fruit. Okay, and we're going to use the standard understanding of integers and fruits. Okay, so red is an integer, false. It's not, it's a color, which is not an integer. And 2 is a fruit. False. Actually, 2 is an integer, but that's not what this says, so that doesn't matter. 2 is a number, which is not a fruit, so false. Both statements here are false, and so it doesn't meet the requirement for a true disjunction that at least one is true. So the or statement overall is false. All right, great work, everybody. Let's recap what we've done here. Conjunctions link simple statements, or at least simpler statements. They don't have to be absolutely simple, because these can be compounded together again and again, and we'll see that down the road. But conjunctions link simpler statements using the word and these are true when both of the simpler statements that make it up are true. Disjunctions link simpler statements together using the word or, and these are true when at least one of those simpler statements that make it up is true. All right, thanks everybody. If you learned anything at all and enjoyed the video, go ahead and like. If you want to see more of this kind of content, please do subscribe. We have more logic videos on the way in this logic primer, as well as plenty of other content coming up. Let me know in the comments if you had any questions or if there is some specific stuff that you'd like to see. Thanks again, and I'll catch you next time.